recorded. So I thought, and it's raining, so my hair's gonna fall apart. Such is life. So I thought I would start by going through the homework from last week, just kind of give you a little idea of what I did. There's always more than one way to solve it. And then I'll see if you have any questions, if that makes sense. So let me go ahead and share Eclipse. Okay, so this one is, I assume everybody can see that. I can't see anyone's faces, so I'm not sure anyone's really there, but hopefully someone can see this. On this one, it's the even or odd, and that one I'd posted a video on before. No, it's not. That's wrong. This is the one that's the inner 5 integers, and then we got the largest. That's what it is. What's up, Barbie? Get it? Okay, so in this one, basically, I went ahead and set up integer for all of these. You didn't have to do that. I mean, you could reuse fewer variables if you want, but that's just how I decided to do it. I also did a largest and a smallest. We didn't necessarily see this yet, but you can do one int with a comma delimited list and do a bunch of variables if you want. Okay. Then I ask the user to enter the first integer here, and then I use the input. I've done my scanner input from before up here. Okay. And I'm going to right now. So if you're looking at the state of affairs, I have one number. So it's both the largest and the smallest. So that's why I set the largest equal to that number and the smallest equal to that number. Okay. Move on. Barbie's having trouble. Looks like getting in. It happens. I go on to enter the next number, and then I'm going to check to see, is this next number, okay? And this could be the same integer over and over. It wouldn't be a problem at all, but I decided to make it a little more readable, I think. So this next number, is it bigger than the largest? If so, it's the new largest. Is it smaller than the smallest? If so, it's a new smallest, okay? I'm gonna keep going on from there, okay? And when you run that one, enter numbers. If I enter a 5, and a 3, and then a 7, and a 1, and then a 3. Let's do something else, a 2. Okay. It correctly tells me the largest is 7 and the smallest is 1. Okay. Questions on that one?
Is there any way to make that screen larger? I'm full screen. Your
Is that any better?
well, not for me, but
This text any bigger? I don't know if I can or not. Is that better?
no, I can't see it on homework either, though. So
Okay.
I go by ear and look in the textbook because you usually use the figures in the textbook.
Gotcha.
Sunday.
Okay. Yeah. So that, any other questions on this one?
Napkins are out there.
Okay, make it a little bit bigger there. A little smaller so I can get more of it there. Okay, see how it goes. Okay, so the next one. Yes.
Just one like general question. When you put in next int, what
Yep.
does that actually mean?
It's going to accept from the standard input, or from the input, which we have determined up here as system in, the next thing to come in, and it's going to be an integer. Okay, it's going to test it for us.
So if you tried to put in a string, it's looking for an integer and it wouldn't work.
It'll blow up. Let's try that. I put in Bob, blows up.
Okay. Okay.
Now-
So that just means that it's looking for an integer. So that's why, like, if you put in next, I mean, I guess essentially you could put in next string too, or
Yeah, next float, next whatever. Yep. And all in the same
Okay.
input. So down here I can just say like something A is equal to input dot, and it's going to pop up all these guys.
Okay.
Okay.
So that just tells
Options.
the computer what it's wanting from the person that's inputting the data.
Yes.
Okay.
And note, as a preview of coming attractions down here, it's going to throw, it will say here, this input mismatch exception, we're going to be able to capture or catch that exception and do something about it later. Right now, it's just going to say there's a problem. We'll eventually get to where it can tell the user, oh, you want to do an integer, try again. We're not there yet, but that's where we're headed.
Okay.
Okay.
Thank you.
No problem. Any other questions on this one?
The bracket, this is just a general question. The brackets, are they like parentheses? You have to have an open one and a closed one
Yes.
before you move on, or? Okay.
Yes. Again, they're by structure. So this if needs, that's the opening if, and that's the closing if. Okay, and if you click on one, it'll tell you the pair, which is an interesting thing in this editor. So if I click here, I'm like, oh, where does that go? Oh, it goes right there. See, it puts a box around it. Okay, and again, in Java, as in most languages, if you just put it on the next line, you don't have to do brackets. That's okay because it's only one line. If I had more than one line, that wouldn't be okay. Because remember, we're not in Python. It doesn't know. In Python, the spacing tells you you're inside of that if. In Java,
and would it count it?
Yeah, go ahead.
Would it not run correctly if you didn't have them in the right spot?
Well, yeah, it may not. If I put another line in here, whatever it is, this line is not part of this if. This line is just out on its own. Okay. So that's why I always like to put the brackets in, just so it's clear. And often, if it gets confusing, you can put in a comment there that ends the if, just so you know. Okay. Okay, let's look at the next one here, which should be 25. 25 is even odd, and I did a video on that. Okay, so that one should be okay. Okay. Next one was 28. This one is the circle. Okay, so on this one again, and I tell you, a lot of what I do, these programs are similar. I just cut and paste the last program into the next one. So I have a basis to start with. You have to make sure you change the name again, but that's the basic idea, okay? So we still have a scanner. We can call it whatever we want. Again, this input is not special. You could call it Jack if that makes you happy, okay? But input's what we use. There's an advantage in using input is in that you don't have to think about it, right? We don't have to worry what is our input called. It's called input, always, okay? So this one we're going to get, as the book says, to use an integer for the radius. It could be a float or a double, but it's not. So we're doing the int here as a next int. And then from that, we're just going to have these series of system printouts. It told us in particular to not use a variable to calculate these numbers, but to put it right into our printf statement. Okay, so over here, I've got, and again, the printf, this part is the format string. It's what it's going to look like, except we're going to put in something where these percents are. Okay, so our output when we run this is going to say the diameter of the circle is, the percent %d is going to be replaced by the 2 times the radius, and then the percent n's a new line character. Okay, same way here, I'm using the circumference of the circle is, this time I'm using the percent %f because I'm getting a float because I'm using the math.pi, and I kept putting small pi, which it did not like at all, but it's capital P, capital I because it's a constant. So it's 2 times radius times math pi. That goes into this spot. Same thing down here with the percent %f. And if it's a float or a double, you still use a percent %f for either one, okay? And then we do the math pi times radius times radius. There's a way to do a squared. We don't know how to do it yet, so that's why I'm doing this, okay? So I run this one. I'll get, let's say 10, and it's going to print out the diameter, circumference, and the area of the circle. Okay, there's a math.py in Python, but I think you have to import the math library for it to pull in. If you put 3.14159 or even 3.14, not a big deal. The math.py is better to use. It's got the full accuracy of whatever computer system you're on, but that would be okay for this case. Questions on this one? Okay, let's move on to 30. This one I think we also did in class last time, should be on the video. So on this one, we've got another scanner. We're going to input a 5-digit integer. Again, if you enter something that's not 5-digit, this is not going to work. And the book says just to assume people are okay and enter what you want. Okay. And this one I was going through, some people did it from the ones place forward, but I do it from the biggest numbers. So I start, again, I'm doing this n divided by 10,000. The 10,000 is an integer, n is an integer. So this is integer division. It's going to lop off any decimal portion. So if I enter 1, 2, 3, 4, 5, it's going to take 1, 2, 3, 4, 5 divided by 10,000. It's only going to be 1, right? Okay, because it would normally be a 1.2345, but it lops that off and just gives us a 1, which is that place. Okay. I then have to change my n with the mod 1000. The mod 1000 will take 1, 2, 3, 4, 5 and get rid of any 1000s, or sorry, 10,000s that we have. Okay, which is going to give us 2, 3, 4, 5, which is what we want. Okay. We do the same thing again by 100, or by 1,000, by 100, and by 10. And then when we're done, the last thing after this one, n is the ones place. Okay, so run this one on 5, 4, 3, 2, 1. We get, and I could have made the printout nicer and said this is the 10,000th place or whatever, but I did it cheap and dirty. Okay, the 5, 4, 3, 2, and 1. Okay. Questions on this one? Okay. And I think this is the last one. This is the world population one. One problem I ran into, you may have ran into it as well. If you try, and if your numbers are different, it doesn't matter. There were multiple sources I found, but it's basically 7.8 billion. If you try to put 7,800,000,000, your integer is going to blow up and say that it's out of range. Okay. So you have the option there, and I just didn't, the book hasn't talked about it yet, and I was going to Google it and just decided not to. There is an integer type big enough, probably a long or maybe a long or something crazy. But I thought instead, nobody wants to see that many zeros. I'm just going to make it 7.8 billion. Okay. So I made the 7.8 a double. So I'm setting my population to be 7.8. And then when I print it out, I print the billion there. Okay. And then the rate I found is 1.2%. 1.2% is 0.012. Okay. So I start by printing out the current population. And again, this %F for a double or a float on the population is going to print out the current population. Okay. And then for each additional year, so after 1 year, I could multiply by 0.012 to get the increase, and then add that to the last total, but I can also just multiply it by 1.012. So I'm adding 1 plus the rate, multiplying it there, and then printing out after year 1, do the same thing after year 2, all the way up to year 5. Okay. So that's what this one looks like. Oh, and I'm missing a %n right there. You always want to make your programs nice looking if you can. That looks better. Okay. In fact, I may want to put in 2 of those. Okay. Something I found out today when I was working on chapter 3 homework, if you want for some reason to put in a tab, you can do a \t just like you do in Python. So that \t will tab those numbers over, which may make things look better. Okay, so that looks a little nicer. We're going to be able to format these numbers differently later, but we're not there yet. Okay. And you had a little more flexibility on this one on how you worded it and all that, but that's the basics. Okay. So that's the homework from chapter 2. Are there questions about that, or about anything in chapter 2, or about anything anywhere? Okay. Moving on to chapter 3. So you got homework for chapter 3 coming up. And let's look at the example that I did from on the video for this week. And this is on the account class. Okay, so I think it's really important in programming that we develop habits. So we follow the same steps. Okay. So when we're doing a new class, I think it's important. We have our public class, whatever the name of the class is. And again, this name here has to be, it has to be in a file called account.java. So the file name has to be exactly the same. If I would change that to a small a, it's going to give me errors. Okay, it has to be a capital A. Okay, if I rename the file, I'm going to rename that. Okay, the first thing we're going to do here at the top is we're going to put in our attributes or our member data. Okay, and those are going to be private. Again, we want to do information hiding. We want to hide that data so other objects can't get to it without us having some control. Okay, so put that at the top, private. We have a string with a name. We have a double with a balance. Okay, the next thing we're going to do is going to be the constructor. The constructor is a method or a function that has no return type because it's special. It's a constructor. So it's public, same name. So we have the same name of the constructor as we do for the class. Okay. In this version of the constructor, we have a string called name and a double called balance. Okay. Then we're going to say, we want to set the name for the object we're creating. Okay. Again, account is the cookie cutter. We're creating an object. Okay. That we're going to call, well, we haven't called it yet. We're going to call whatever we call it. We're going to call it in another program. But that new object, the this refers to that object that's calling this. Okay. So that name we're setting equal to just name. If this were in instead, we could say that and we'd be okay. Okay. But what we can't say is name equals name. Okay. I mean, we can, but it's giving us a warning that that's just nonsense. Okay. So the this.name refers to the name and the object. This name here, and if you click on it in Eclipse, it shows you, refers to this name. Okay. So this name refers to the name up here in the class. This name refers to that name. Okay. And then it asks,
David,
yes.
can I ask a question?
Sure.
So this is just kind of like my understanding. So essentially, like when you create the class account, you're saying that the two parameters, and I probably am not using the right word, that you're going to use for that you're going to accept from account is going to be name and balance.
Right. It has to be a string. It has to be a double. Yes.
Right. And then if account, the public account is almost like a function, and you're saying, okay, you're going to get name and balance that you're going to do something with. Is that correct?
Nearly. What we're doing here, so remember the account, there's nothing called account in our running program, right, that we can do. There's going to be an account called Bob, an account called Alice, an account called whatever. Okay. When we create that account, we're going to use a special function called a constructor. So that's what this is. This is the constructor. This makes a new object of type account. Okay. And what we're saying is, if we're going to have an account, we can't create one unless we have a name. So unless we have a string and a double. Okay. If we have a string and a double, we can create an account. Has to be in that order. Can't be the other way around. Okay.
Okay.
You can overload the constructor if you want. If in the program you're writing, and it doesn't make sense here, but maybe, if we have a public account with no parameters at all. Okay. Now you can't normally have functions with the same name, two different ones, unless they have what we call a different signature. The signature is the number and type of parameters. So this has a string and a double, this has nothing. Okay. So in here, I would just say name is equal to whatever default. And it doesn't make sense for this program. I can type. Balance is equal to 0.0. Again, this program wouldn't do that. But I mean, I guess it could be that we can set up a new account with just the name. And then we wouldn't have, then we would have this name is equal to name and the account balance equal to 0. And that's okay. Okay. How will it know which constructor to use? If we send it just a string, it's going to use this constructor. If we send it a string and a double, it's going to use that one. Okay.
So the constructor just kind of sets it up and it like basically sets the variables.
Yes, it sets the variables. Yes, it sets these value for these. That's all it does. It runs
Okay.
one time. It only runs when it's created, never any other time. Okay.
Okay.
Okay. So once we've got our constructors going, okay, the next task is to have our accessor functions and our mutator functions. Okay. The accessor functions, because these are private, we're going to be able to determine whether or not we want others to see what's going on behind the scenes. Or if we want to see the value of these variables. So all we have these for, so for every one of these up here, every one of our member data or our attributes should, unless there's a reason not to, sometimes there's not. If you're doing a program on loans, for example, you may not want to give anyone access to the interest rate or whatever secret sauce you have. But in this case, we want other programs, other objects of other types to be able to get to the name and the balance, okay? So we're doing that through these accessor functions. Again, they can be named whatever you want, but let's not think any more than we have to. We have enough on our minds. We're going to call them get whatever this name is. Using the camel caps, a camel cap, you run them all together with no spaces or underscores, but every new word has a capital letter, okay? So if I've programmed correctly, if you give me a class that has an attribute called, it doesn't matter, baboons, okay, maybe you're in a zoo program, then I should be able to, if I want to get my accessor program or your accessor program for this program, it should be get baboons, okay? If I want to change the number of baboons, I should call the set baboons. Again, those, what's the word I'm trying to use? It's Friday. It's raining. Raining makes me not be able to say words or think of words. These habits we get into, this convention that we use. It doesn't have to be that way, but if you find a way and stick with it, it makes your code easier. You don't have to think, what am I going to name my accessors? What am I going to name my mutators? Or what did somebody else name them? So you stick by the rules, it's better, okay? All the accessor functions look pretty much just like this, okay? It's going to be a public function. If it wasn't a public function, there's no point in having it. Because these are private, we need this public function. The return type of the function is the return type of the variable. And then the function name takes no parameters. All it does is return that name, okay? And you may be thinking to yourself, that's dumb, why do that? The name's right there. It's because if you were looking at an object in another program, it's got a fence around it and the fence is opaque. You can't see inside. You can only get inside through the getName function, okay? The getBalance works the same way, except that it's a double. Otherwise, it's the same, okay? So those are the accessor functions, or the setters. We also have the mutator functions, which are the getters. I just said those wrong. Let me back that up. You guys got to catch me. The accessor functions are the get, we're getting that. The mutator functions are the set, where we're changing it, okay? So often we would have a set name and a set balance, okay? But really letting someone change the balance of their account on their own, probably not a good idea, okay? So oftentimes we will have some extra math we have to do there, okay? If we have a person class that has an age variable, then if we have a set age, if we're going to allow that, someone can change the age. We're going to make sure it's not less than 0. We're going to make sure it's not more than 115. Okay, so if we just made it public, we wouldn't have that control. So it's in the mutator functions, we have control over the state that our object can take, okay? So in this case, they've decided in the description of the program that balance we don't want people to be able to set directly, okay? So there's no set balance. But we do want them to be able to change the name. People get married, they change their names, they get divorced, whatever, okay? So again, it's a public function. The public function just means that other objects can see this, okay? And then we have a void, it doesn't return anything. Instead, it's going to take a parameter of the type that we want, and it's going to set it there, okay? Note that the mutator function looks just like this up here, okay? This line and this line are the same, okay? And if we had a get balance, it would look just like this. Okay. But we don't in this case. And again, what this is doing here, the problem said if only let them set a balance if it's greater than 0. So we've got if balance is greater than or equal, or greater than 0.0, then this balance is equal to balance. If not, we don't do anything. Okay. If we don't set the balance, what's the balance equal to? Is it equal to 0? Java, I don't know. We have to test that and see. Because in C++, I know it would be equal to some random number. I'm not sure if Java does it or not. We'll test it here in a minute. Okay. But in addition to the accessors and mutators, we often have other functions, other special features. In this case, we have this deposit function. Okay. It's going to take some deposit amount. And as long as that is greater than 0, we're going to add that to our balance. Okay. So that's what all of that is going to do for us.
Hey, David, I have one more question.
Sure.
Because it seems like you would do the accessor and the mutator functions before you do the methods. Does it matter what order those go in?
It doesn't, and you're probably right. The book didn't do it that way, but I think I probably would as well. Again, you want these formulaic in how you put them. Okay, so you have the accessors, you have the mutators, and then you have, I would almost put a special functions. Or special methods. They tend to call it methods in Java. Same thing. Okay. And I literally put these in just so I remember, just so I'm clear. Okay. Here's my constructor. They're comments. You don't have to have them. They're not necessary. But I want them there so I can keep track. And I'm going to go in the same order every time. Okay. And then when we look at our test program here, okay. So the book talks a lot about it, and I mentioned it on the video, but just so we're clear on this, if you were running this from the command line, then you would have to have both class files in the same directory. There's no importing or inserting or anything like you do in other languages, okay? They have to be in the same place. Eclipse keeps them all in the same place unless you take pains to put it someplace different, okay? So we don't have to worry about that as long as you've saved them both in the same area, okay? Which it should do automatically. This should have some comment block, but I got lazy and didn't, okay? So this we're going to call account test. But again, for the homework, you know, the book, I think well, here are the two. There's an employee class and a date class for the homework. It says to name an employee test and date test. That's okay. But for me, I just named the test program, the chapter, whatever program, whatever. But whatever keeps it straighter in your mind is okay with me. But it should be either, this one should be named either C3, P14, or should be named date test. Either way is okay. Okay. So this one's going to have our public static void main. Again, the account.java did not have a main. Okay. Account.java, you can't create an account out of the blue, right? It's got to be part of another program. Okay. Was that a question?
David.
Yes.
I'm so sorry. I'm full of questions tonight.
It's okay.
And this is just a particular, being particular kind of question, but why is it that you have to have two files? I mean, why could you not actually add the stuff with account that you have for account and like set it up before you actually run the accounts? You
could, but that's not how Java does it. And it's just yeah, I mean, yeah, there are other programming languages. I know in C++ you can mix them all together, but Java wants a clear distinction. And part of it is reusability. This program uses the account class. We could write 100 programs that use the account class. And you don't want to tie that up with this particular program. So it adds to modularity. Okay.
Okay. Thank you.
Okay. So again, if it doesn't have so let's go to here. If I run this, I don't even know what it ran. It ran the last one I ran, which is really weird. I don't know why it ran that. Yeah, I guess there's nothing to run, so it didn't. That's really weird. But there's no main to this, so we can't run it. Okay. But this does have a main. And in it, I'm setting up an account. Okay. And it's important. This doesn't do it, but it's important when you're writing a program, and the book usually says this. you want to test every function that you have. Okay. So in this case, we're setting up an account 1 and account 2. Let's go ahead and try our new constructor we made and do an account 3 is equal to new account. I'm going to call it Bob Purple to keep with the name. Okay. So these two both have a string and a double. So they're going to call our regular constructor, the first one we had up here. This one has just a name. It's going to call that second one that we just added. Okay, down here. It should set the balance equal to 0. We'll see how it goes. Okay. This is the initial information for this, but we also want to test our balance program. Okay, so that's the get name. So let's do, we also here, let's do something different here. That's the name for account 1. Let's go ahead and do the balance. Okay, so I want to do a system.out.printf balance. And that's going to be a percent D, no, F. Okay, and that's going to be, again, I can't get to that. And we can just try that. I could say, if I wanted to, like account 1.balance. That's what we'd like to do, right? Okay, but that's private. I can't get to that. So instead, I have to put in the get balance, and that's a function. Okay, so I can get the balance from that account. Copy that down. On account 2. Okay, then I can do the same thing on account 3. If you got paste, just make sure you change everything or it won't work. Okay, that should be okay. So I've now tested my get name and my get balance. If I look back over here, I had a get name, a get balance, a set name. I need to change that and test that. And I also had a deposit. So I still need to test those two. Okay. So the set name, let's say Jane gets married. New last name or new name, whatever, is Smith. Be very patriarchal and assume she takes her husband's name. Some people do, some people don't. Okay, so this would be on account 1 dot set name to Jane Smith. Okay. I don't know what that just did, but that was weird. So let me go back and fix that. Okay. Oh, still got it. The automatic parentheses are cool until they mess you up and put them in the wrong space. Okay, that should be good. Okay. So now let's give John a deposit of $100. Okay. So that would be an account 2 dot deposit with a deposit amount of 100.0 to make sure it's a double. Okay. And now we can print the new information. And again, I would just copy all this stuff. To make sure that it's working. Okay. So now I've tested every function and we'll see if it works. Okay. Run this again. Account 1 is Jane Green. Oh, I've got, that's ugly. It's ugly right here. It's ugly a couple of places. I don't think it's ugly. Get rid of one of those there. Put one here. And I never know what that's going to look like 100% until I do it. And I'm like, that wasn't good. I got to fix it. I'm just going to fix these for this. The rest should be okay. It should be close enough. If any of the things I'm typing make no sense to you, make sure you let me know. Okay, so we can move this up a little bit, see what we got. So we've got Jane Green, who has the 100.34, which I can look up top and see that's correct. We have John Blue has 234.56, which is correct. Again, we're not formatting it correctly yet. Bob Purple has an account balance of 0, which is correct. Okay. We now see when we start again that we've changed Jane's last name to Smith, which is correct. Her balance stays the same. John Blue's name stayed the same, but his account we deposited 100. That's okay. And then nothing changed for Bob Purple. So we're good. Okay, we've now tested this program. Okay. The other open question that we had that we might as well resolve while we're here was if we tried to do something with a negative number, what that balance would be. Does it set it equal to 0? I think Java does make it 0, but we'll see. Yes. So Java takes care of you and doesn't put random junk. C++ will put random junk. Okay. So are there questions about this? Again, follow this pattern for the 2 homework problems. The homework, you have an employee class you're setting up and you have a date class you're setting up. Should look just like this. Okay. Note also that the book says at this point, we assume if they enter a date like a year or a month or a day, that it's legit. We're not going to check yet to see if things are correct. We're going to need to verify at some point. You don't want to write real programs where you don't verify the input of users. But for now, it's okay.
Hey, David, when you
Yes.
set up the dates, would you set them up as strings or integers?
Integers, you can do it any way you want, but the problem in the book calls for them to be integers.
Okay, so would you set it up with like the backslashes? I mean, how do you do that?
The print would do that. You would maintain the day, month, year separately. So you would have 3 different, so up here.
So you would prompt them for three different,
Yep.
like give me the day, the month, and the year.
Yes.
Okay.
Yep. Yeah, you have all 3. And your constructor would have to deal with all 3 of those as well. And that means you would have, I think the program asks for, it does ask for a display date. The display date is where you put the slashes in between it. But you also have to have the accessors for all 3. So you have 3 accessors and 3 mutators. So 3 gets and 3 sets for that one.
Okay.
Yep, that's problem 14. Okay. Other questions? Okay. If
So
you see, okay, go ahead. Yes.
when you said to test everything,
Yes.
so the employee test needs to test everything that's in the employee class?
I mean, for the homework, you can do what it asks. I don't know if it asks you to test everything, but in general, if it were me, I would test everything.
Okay.
I'm not going to count off if you do what they say. But just as again, as a programmer, I programmed a long time, and you learn to do the same things, even if it doesn't matter. Does that make any sense? Just not to have to think about it. You know, so I know every time I write a class, I'm going to test all those functions, all those methods, just in case they blow up later. But if the homework doesn't ask, you don't have to do it.
Well, but David, if we're submitting our programs to you, is that something, I mean, we can test them for ourselves to make sure that ultimately when you run the program, they work, but is that something that you actually want to see that they are being tested while the programs run and what we turn in?
Yeah, I would. I mean, again, if the book will ask you to do some of that. So if I were going to turn in the account object here, the account with the account test, this is what I want to see, you know, because this has everything we're going to need, right? This has all the gets, all the sets. No, that's the account.java. Where is it at? Here. This has everything. This tests every one, all the accessors, all the mutators. It tests the get name, the get balance. It tests the deposit and the set name. Okay.
Okay.
And all constructors. You know, we have 2 constructors, so we did 3. We didn't have to do 3. We could have just done 2. But if your object has, or your class has 10 constructors, then you want to test 10 different objects to make sure they all work. And this is not a program you would, again, this is the account test program, right? This is not doing anything real. This could be used as part of a bigger system, but this is just the test, okay? And you would maintain that along with the class. So if anybody else, so let's say that, you know, if you're the new programmer, I know you guys don't want to be programmers, but your students may. If you're the new kid that works there, someone's going to say, oh, instead of a name, we want a first name and a last name. So you have to go back to this one and change it. Well, if they already have the test program with it, you just have to modify that. You don't have to write the whole thing yourself. And it just makes it easier for everybody.
Okay.
Okay. When you see the asterisk in the name here, it means you haven't saved it yet. So you can always do a file save. If you run it, it will save. But remember, you can't really run the programs without a main. Okay. Other questions? Okay. If that's it, then we'll stop there. Let me go back to the main thing here. We'll talk a little bit about next week. And again, I'm sorry, it was a weird week this week that I was out of town and I got locked out of all the systems somehow. So the video went up. Well, this week will be weird too. There's no class Monday, whatever that means, which means the video for the week will go out on Tuesday. Okay. But I think we're covering 4 and 5 next week. Okay. So chapter 4 is on control structures. Okay. And I assume that you've seen this before, the ifs, the else. We've already seen the if, but we'll have an if else. We'll have the repetition structure with a while. Okay. So we'll have that to go over, and then we'll also hit chapter 5 next week, which is on something else, on iteration. So it's on for loops. It does while loops again, but then it does for loops as well. Okay. And it also does a switch. We have a switch in Java. Okay. So the reason I did those together, if this were an intro class you'd never programmed, I wouldn't do that. But again, my assumption is from Python that you understand what an if does and what an if else does, and you understand what a for loop does and what a while loop does. So I won't be in my video talking about what they do. I'll be talking about how we do them in Java. Okay. So that's my assumption. Okay.
Hey, David, can I ask one
Yes.
more question?
You can.
At the end of chapter 3, they talk about the, I guess, the graphic user interface.
Yes.
Is that something that we need to go through? I mean,
not yet. I haven't tested it out to see if it's easy or not, if it needs a bunch of software. And I figured this week we wanted to get just that, but I will look at that this weekend. If we have everything we need and it's not going to be a big pain, then I think the graphics would be kind of fun if we have time. But it's not the main thrust of what we're doing. But then again, if you're going to be writing programs you want to use in your classroom, having the graphics could be useful. So I'll have to see. I know in Python, the graphics are kind of a pain to get everything installed. So let me look through that a little bit more and make sure it's okay.
Okay, I just wasn't sure because like I got to the end of like the account programs.
Yep.
And just wasn't sure if that was something that I need to kind of keep trudging through or just hold off on.
I think in the video I said to ignore the graphic stuff for now.
Okay.
So certainly look at it, look at it, try it, see if it works. That's fine. But I just didn't want, it wasn't an obligation yet. So there's more of that coming up in the next week, and I will take a look this weekend to see it, again, if it's all there and it's easy to do, which it seems like it may be not too bad. I think it's more built in than it was in Python. Then it's certainly something we'll look at because I think it'll make better programs to have it on a window with little graphic looking things. I think it'll look better. But I just didn't want to. I thought, I don't know, maybe correctly, maybe not. I thought the classes could be a lot this week because Python doesn't really do classes. But if you did classes in Python, good, but it's usually at the end just a little bit, where Java is all class all the time. So I just wanted to make sure that you had time to focus on classes and getting Eclipse running and everything else before we hit the graphics. But I'm not anti-graphic, so that should be
Okay, thank you.
okay. Other questions? Okay, if you have questions, let me know. We can try to get together in Zoom. I will record this video and put it up there. Next week, we'll probably do a Thursday again on the alternating back and forth and see if that works. Okay. Okay, if not any other questions, that's it. Have a good Memorial Day weekend, and I will see you guys via video on Tuesday.